Well, hello everybody. Welcome to this episode of Master the NEC, where we talk about the National Electrical Code. If those of you who are listening on our podcast, broadcast from our Spreaker website, or as well on our website at www.electricalcodeacademy.com or masterthenec.com or electricalseminars.net. One thing we want to announce new, in case you didn't know it, is that in the state of Texas, we are now a CE provider for continuing education for master electricians, journeyman electricians, apprentice electricians, sign electricians. Texas has a slew of electrician classifications. So we're offering the continuing education program, the 4-hour program for that, a half hour of TDLR, which is the laws that apply to the electricians. We'll be doing a half hour of electrical safety. Basically, that's NFPA 70E, maybe a little bit of OSHA mixed in there. And then we're also going to do 3 hours of National Electrical Code changes. So look for that in your area. Visit our website. If you know somebody in Texas who's looking for one of those seminars, send them to our website. We'll be able to hook them up and let them know about an upcoming seminar near them. So we are also now doing our podcasts live with our video streams. So we can have both available if you want to listen to the shows via podcast. Just simply go to our website, click on the link for podcasts, and you can listen to all the podcasts from our show. From here on out, we'll be doing that so that we can offer two options for people listening while they're in the car, wherever they might be, but also those that want to watch the video. So we show the code book or maybe some graphics in some cases. Well, on today's show, we're going to do one that I promised. We're going to do 250.122F, and we're going to talk about parallel applications for equipment grounding conductors. We're going to jump back and forth a little bit in the code, so those who are on the podcast won't be able to follow along until you get home, and then you can follow along in your code book. But you really won't need it because we're going to pretty much talk about it we're going to paint you a picture, if you will, so you get a better understanding of it. Again, my name is Paul Abernathy, and I'm the founder and CEO of Electrical Code Academy Incorporated. And I'm also founder of Master the NEC, where we talk about the National Electrical Code. So if you have any questions before we get started, you want to email me for an upcoming video or an upcoming podcast, feel free to do so at info@masterthenec.com, or you can send it at info@electricalcodeacademy.com. Either way, I'll get your message, and we'll try to develop a show that might be geared towards teaching you something, or maybe there's something that you're confused about and you want somebody else to understand it, maybe an inspector or vice versa. Feel free to let us know. We're more than happy to do a show for you. Okay, so on today's episode, we're going to talk about equipment grounding conductors, and most notably the issue that's the biggest change for the 2017 NEC when it comes to what about that application where I have parallel sets of cables in maybe the same cable tray. And since I'm running them in parallel, the stock MC or stock tray cable, the equipment grounding conductor is not sized fully for the parallel application. Let me explain more detail. If I'm running an MC and it's a certain size, let's say it's a 4-aught, and I know what the overcurrent protective device is based on the size of those conductors, based on the ampacity of that conductor, and then I go to 31015B16, find the ampacity, then I go to 240.4 and I determine what my protection has to be for a conductor. Then I go to 240.6 and I select the overcurrent protective device. Once I do that and I know the overcurrent protective device, then I need to know the size of the equipment grounding conductor. Then I go to 250.122, and then that determines what size overcurrent protective device or conductor I have based on that device. That is traditional way to do it. Now, when you buy a cable assembly that's already designed for its application, and remember, cables are designed that way. So if I got an MC cable with 4-aught conductors in it, chances are those conductors and everything in there is going to be sized so that the overcurrent device protects those conductors. Now, when I run them in parallel, I'm doubling that. So if I had a conductor, let's say that was good for 200 amps, and I paralleled it, now I have an application where it's good for 400 amps. Now my overcurrent protected device is 400 amps, but the cable itself is only good for 200. So a traditional 200 amp overcurrent protected device is going to provide for a smaller equipment grounding conductor. But now, since it's parallel, I have to have the equipment grounding conductor full sized in both raceways or both cable systems in this situation in order to be able to protect it with that 400 amp device. So it's got to be a larger size. Now, traditional cables won't have that oversized equipment grounding conductor. So the 2017 code and Code Making Panel 5 developed some applications here where if it's in the same raceway or in the same cable tray or same auxiliary gutter, then you can do a little application in order to run an individual equipment grounding conductor in with those paralleled cables in the tray, let's say, a cable tray. And as long as it's full-sized and it connects intimately with the other sized equipment grounding conductors that are provided in each individual cable, and they come together at their termination point, basically paralleling them, if you will, then what happens is you're allowed to do that, and you can use that stock cable with that individual equipment grounding conductor that's only sized for that one cable. Okay, so let's look at that in the code, and we'll kind of get a better understanding of that. So those that are following along on the podcast, we're going to be going to 250.122F. Now this changed in the 2017, so it's been broken out into some new areas. So there's an F1 and an F2. So 1 is pretty much the rule of thumb we've always had. We're kind of just briefly look at it, but really we're more geared towards looking at F2. But we're gonna look at both of them because we want to make sure everybody understands the application. So let's go to the code. And again, those following on the podcast won't have the luxury of that. Excuse me, but you can follow along as you get home. So we're at 250 grounding and bonding .122. It's equipment grounding conductor, and we're at item F, which is conductors in parallel. Okay. Now the first thing we want to go is the charging statement with F, and F says for circuits of parallel conductors as permitted in 310.10H. That's the requirements for paralleling. Same material, same size, same insulation, same length, all that kind of goodies. The equipment grounding conductors shall be installed in accordance with 1 or 2. Okay, so it's 1 or 2. Now again, it's depending on your installation, depending on your application. But let's look at number 1. All right, number 1 here says conductors installation in raceways, auxiliary gutters, or cable trays. Now, remembering auxiliary gutters are additional space afforded in an enclosure. It means you might need additional space for wire bending, whatever. It's associated with an enclosure application, not to be confused with a wireway, okay? But it is very similar, and it adds extra space to a piece of equipment. It might connect two pieces of equipment together, things like that. So, not to get that confused with a traditional, just the term wireway. Okay, let's get started on it. All right, there's an A. So what does A say? Now A says it's single raceway or cable tray. So we're talking about one single raceway or one single cable tray that we're going to now run parallel conductors in. It says if conductors are installed in parallel in the same raceway or cable tray, a single wire type conductor shall be permitted as the equipment grounding conductor. All right, so that's really no different when we run multiple conductors inside of a raceway, and as long as we size the equipment grounding conductor to the largest circuits over current protected device in that raceway, then obviously we only need to run that larger equipment grounding conductor. So the same applies here when we're doing a parallel application. That might have been individual branch circuits and multiples, but this is the same concept, but it happens to be a parallel application. So I can have a single wire type conductor is going to be permitted. Now, it says permitted, so I could have individuals for each, but it's permitted to have a single, okay? Now, it says the wire type equipment grounding conductor shall be sized in accordance with 250.122, and we've already talked about that's based on the size of the overcurrent protected device. And of course, it goes on to tell you that. It says based on the overcurrent protected device for the feeder or branch circuit. So that's normal. We already understand that. It says wire type equipment grounding conductors installed in cable trays shall meet the minimum requirements of 392.10b1c. Okay, so that 392.10b1c is going to be the requirement for it to be equipment grounding to be 4 and larger. Okay. It says metal raceways and auxiliary gutters in accordance with 250.118. So that also says that the equipment grounding conductor could be the raceway, it could be the gutter, okay, and it could be the cable tray if it complies with 392.60b, okay? All of those are allowed to be an equipment grounding conductor. Of course, we're going to talk about the wire type today, but you do know that if you meet the requirements that you can use the cable tray itself, provided you meet all of the requirements in 392.60b for that, and 250.118. Obviously, you can use metal raceways, and if the auxiliary gutter is connected to the equipment, to the enclosure, then that could be utilized as well in certain applications. So we got all that covered. That's not really a change too much. That was there before. All right, so then we go to B. Now B says multiple raceways. So the first one we're dealing with a single raceway. B is dealing with multiple raceways. It says, if conductors are installed in parallel in multiple raceways, which is very common, it says the wire type equipment grounding conductor where used, again, so it says where used, so it means it's not required to be done that way. I could have a metal raceway that's being utilized in accordance with 250.118 if it meets it. That could happen, okay? So it's telling you where it's used, it shall be installed in parallel in each raceway. The equipment grounding conductor installed in each raceway shall be sized in accordance or sized in compliance with 250.122, and it's based on the overcurrent protection for the feeder or branch circuit. All right, and then it goes on again to tell you about metal raceways, auxiliary gutters, where they meet 250.118, and then, of course, cable trays that meet 392.60b can also be equipment grounding conductors. Well, here's what it's really saying. If I run parallels and I run equipment grounding conductors in parallels, then that equipment grounding conductor has to be full-sized in all of the raceways I'm running in parallel, okay? You're not paralleling that conductor. You're not dividing it up like you do with phase conductors in order to get a certain number of ampacity. Here, we're talking about a full-sized equipment grounding conductor in each multiple raceway, okay? So that's the one we don't want to get lost on. That rule didn't change. That's the same rule as it always been for that, okay? Here's the one we really want to focus in on, and what I'm going to do, those that aren't watching on the screen, or that are watching, that are listening on the podcast, you can't see it, but what we're doing is we're going to focus in on item 2 here, and that is multi-conductor cable, because here's where we're looking at understanding some of the basis of the change, and it's new. Now you will notice in your code book, why is it not grayed out if this is new stuff? That's because when you see grayed out things in your code book, that means there's a change from the previous cycle. Here you see that little N to the left, and the N is grayed out. That means all of this information is new. That doesn't mean all of the verbiage is new. It's not like we just created all this. This could have come from a previous code edition, but how it's placed in here and how it's broken out is all new. So this is kind of a new section, if you will, or a new item, F, and how it's broken out into 1 and 2. Okay, enough of that. All right, so number 2, multi-conductor cables. What are they? MC cable, tray cable, non-metallic sheath cables. All of those type of things are multi-conductor cables. So this applies. Okay, so it says, and we'll look at each one of them. A, if multi-conductor cables are installed in parallel, okay, so we very frequently have two MCs installed in parallel to get a higher ampacity value, which means that the overcurrent protected device is going to be larger than it would be for one MC, clearly, obviously, right? So, if multi-conductor cables are installed in parallel, the equipment grounding conductor in each cable shall be connected in parallel. Okay, so we still have the same parallel requirements for our equipment grounding conductor connected at each end. Okay, so the individual equipment grounding conductor in each multi-conductor cable are connected in each end. Okay, so it replicates one complete system. All right, so we got that down. B, it says if multi-conductor cables are installed in parallel in the same raceway. Okay, so if I have multi-conductor cables and I install them all in the same larger raceway, let's say, yes, cables can be pulled in raceways. But it also goes on to say if I have multi-conductor cables installed in auxiliary gutters, or if I have them installed in cable trays. Okay, this is one single cable tray, and I like to use cable tray because it gives a clear picture of what we're talking about. I have one cable tray, solid bottom, open bottom, ladder tray, doesn't matter. I got one cable tray, and I'm putting multiple multi-conductor cables in that cable tray. Okay, once I do that, I can have a single equipment grounding conductor that is sized in accordance with 250.122 shall be permitted in combination with the equipment grounding conductors provided within the multi-conductor cables and shall all be connected together. So that's the new one. So if I buy an MC cable from a wire and cable manufacturer and it comes with that equipment grounding conductor that's sized based on their standard, and let's say MC cable, it's UL 1569. If it was tray cable, it'd be UL 1277. That's going to tell us the minimum size equipment grounding conductor, and it's going to correspond with 250.122 of the NEC. They kind of work together in harmony. But when I do that, it's only sized for that one cable based on whatever that overcurrent protected device would be to protect that one cable. When I install them in parallel, now the whole nature of being parallel in 310.10h is that the conductors are connected at the end. It replicates a single conductor, so current's evenly divided. Most notably in equipment grounding conductor, fault current is evenly divided. Or that it's a full size in each raceway in order for it to be able to handle that fault current that's closer to that equipment grounding conductor's lower impedance pad. that's not going to work when I have parallels. So how do I accomplish that? Well, the code's saying here that I can install a full-sized, based on whatever the overcurrent protected device was for those parallel sets, in that single cable tray, and you can utilize the normal equipment grounding conductors that are already in that cable, but when you get to the ends, they have to be all connected together. So theoretically, if I had 2 parallel MC cables, then I'm going to run one full-sized equipment grounding conductor in the tray, and then when they get to their end, they're going to connect together, and basically what you've got is 3 conductors that are going to come together at the location of the origin of where that panel or where it's going. So that's what the code is allowing now. And the beauty of this is that you don't have to order any special MC or tray cable. You can utilize the standard stock product. Now, it does mean you're going to have to pull a separate equipment grounding conductor in there, size no smaller than 4 gauge, but it could be larger based on whatever the overcurrent protected device is for that parallel set. Now, here's the other neat thing. I could have a single cable tray and I could have another parallel set that's unrelated over here. If that single equipment grounding conductor that I run is sized for the largest of that one or this one, then I still only need one. Some people argue that each one needs their own if you're running that individual single one, as this rule allows. That's just not true, because we're able to run a single one in a single raceway. Well, it's still a single tray. Okay, it's still a properly sized equipment grounding conductor, and we all know that you can tap or splice equipment grounding conductors without a problem, right? We do it all the time. Okay, so that's the rule B. Next one, and if I've lost you, because I talk really quick, and I'm trying to slow down, and I get emails from people, Paul, please slow down. I'm really trying. This is the only time I'm trying. Any other time, I just can't help it. I just keep going. Okay, so bear with me. If you don't understand anything, feel free to email us at info@masterthenec.com or info@electricalcodeacademy.com. Text me at 540-607-0116. Call me up, ask your questions. I'm available to you anytime, because my job here is to see that you learn. I want to pass on what I've learned through the years to you. I want to be able to explain it in a way that you can understand it. So that's why I do these. I don't do these for the money. I do these because I want to help pass on what people have passed on to me. And there's a lot of electricians out there who want this information. I get constant emails from people thanking me for the different shows and podcasts and videos. And I'm going to keep it up, because I know that whether there's those negative people out there, there are those of you out there who really appreciate the videos and the audios and the podcasts. So I'm going to keep doing it regardless of what they say. They don't bother me. Okay, if you're watching the video, now we're down to item C. Okay, so we've established what we can do now if we run a parallel sets in in the same raceway, auxiliary gutter, or cable tray, and we have a single equipment grounding conductor. We now know how we can do that and use the same standard stock cable. Next, it says, equipment grounding conductors installed in cable trays shall meet the minimum requirements of 392.10b1c, so they're going to have to be at least 4 gauge or larger. And we'll go look at 392.10b1c right after this so we can just clarify. Cable trays complying with 392.60b. So we'll try to go look at that. So you know what we need to do is I need to write those down, and I'll remember them, but you know the memory is not as good as they used to be. So we're going to look at these together. So 392.10, we're going to go B1C, and we're going to look at that one. And then we're going to look at 392.60b. And those that are on the podcast, don't worry, I'll read it out loud. And of course, we don't really need to go look at 250.118 because we know that that's a list of what's considered an equipment grounding conductor. Okay, so we'll just go look at these and make sure it complies. All right, so we're just being reminded that that equipment grounding conductor that we are running has to be the minimum size, and it could be the actual tray itself. It's just reminding us that. And then lastly, we're looking at D. Now the D is the one that's saying, oh wait a minute, just so you remember, except as provided in 250.122f2b, which is what we just talked about the cable with a one single full-size equipment grounding conductor for use with those separate cables that have the normal-sized equipment grounding conductor that was designed for that one single cable. And since you're paralleling, it's not large enough because the overcurrent device is going to be much larger than what would normally be on a single cable, right? You got all that. So now it says, oh, by the way, except as provided in 250.122f2b, for raceways or cable tray installations, it's saying, hey, remember this, The equipment grounding conductor in each multi-conductor cable shall be sized in accordance with 250.122 based on the overcurrent protected device for the feeder or the branch circuit. So all this is doing is reminding us, hey, just remember that the equipment grounding conductor in all cables are going to be full size unless you have the ability to use this application. And this application only applies to the same raceway, auxiliary gutter, or cable tray. Okay, so if that is your application, you can use B. If not, just remember that that equipment grounding conductor has to be full size, and you would still have to order specialty cable from the manufacturer if that was your case. Most of the time when you're running them parallel, you're going to run them in the same tray anyway. So that's not going to be a concern. But if you had an application where they weren't in the same raceway, auxiliary gutter, or cable tray, and you were doing parallel applications, remember, this allowance doesn't provide you any assistance here. You're still going to have a full-size equipment grounding conductor in each cable, okay, for the parallel application. Okay. Again, it's whatever the size is of the overcurrent protected device in accordance with 250.122 is then going to tell you what size conductors you need as far as an equipment grounding conductor. And if it doesn't meet the allowances here for the multi-conductor cables in parallel in the same raceway, auxiliary gutter, and a cable tray, then you're going to have full-size equipment grounding conductors like we always had and like how it's required in item 1 we just talked about a minute ago for single raceways or parallel raceways. So hopefully I've explained that all to you and you have a little bit better understanding. So what we're going to do now is we're going to look at each one of these just to get a grip of what we're talking about here. So I'm going to go up and do a search here, and we're going to go to this one. And let's see if we can find it. All right. Not going to find it that way, so it's much easier for me. People say, why don't you use your search feature? Because it's just so much easier for me to not use a search feature and just go find the daggone thing. So what we're looking at is 392.10. And let's see here. Let me zoom out a little bit for those that are on the screen. All right, so it's 392.10B. Here's B. 1.1.C. It says single conductors used as equipment grounding conductors shall be covered, bare, or insulated, and it has to be 4 AWG or larger. Okay, so that answers what I said earlier. It really has to do with the 4 and larger. So it can be bare, it can be insulated, or it can be covered. It doesn't matter, but it's got to be 4 and larger. So that's your minimum threshold for the cable tray application. Okay. All right, so that was that one. And the next one we were looking at is 392.60. So let's go on and look at that because it says it has to meet that. So 392.60 is, let's go back right here. And this has to do with the metal cable trays. It says metal cable trays shall be what? Oh, okay. Hold on. There we go. It says metal cable trays. Metal cable trays shall be permitted to be used as equipment grounding conductors where continuous maintenance and supervision ensure that qualified persons service the installation of the installed cable tray system and the cable tray complies with provisions of this section. All right. So, and it goes on to require it to meet the requirements of 250, all right, to be considered an equipment grounding conductor. So that's what that is. So hopefully you understand a little bit better of the paralleling applications when we're talking about the equipment grounding conductor. If we had to do a summary, F1 is dealing with a single raceway. The size of the equipment grounding conductor is based on 250.122 on the size of the overcurrent protected device. If it was parallel applications, then you're going to have a full-size equipment grounding conductor in those parallel applications. When you get into multi-conductor cable applications, you are getting some reprieve if you're installing multi-conductor cables in a raceway, cable tray, auxiliary gutter. If it's the same single gutter or cable tray or raceway, and I have multi-conductor cables that are only going to have an equipment grounding conductor size based on that individual cable, when I'm running them in parallel, they're too small. I can run a single individual equipment grounding conductor, full-sized, based on whatever the overcurrent protected device would be to protect those parallel sets. Then I could tie them all together at both ends, replicating a parallel application, and that would be an acceptable application, and I could use standard MC tray cable with whatever equipment grounding conductor that came in it according to that standard. That's an allowance there. If it's not in the same tray and it is multiple parallel multi-conductor cables in separate raceways or separate trays for some whatever reason, then I can't do that. I have to go with full size. Now keep in mind that even if I did run those applications in separate raceways or separate trays, that I got to start watching 310.10 H for parallel applications and make sure I meet all those applications. So it gets you get kind of crazy at that point. I think the big rule is that most of the time we're running parallels, we're going to do it in cable trays or doing raceways, we're going to run them in parallel. Okay, and we're going to run them in the same tray, and that's when the allowance is for you to have that single equipment grounded conductor sized full size, and then it connects with the other equipment grounded conductors that are already in the cable. So I have two cables, okay, two MC cables. They both have their own equipment grounded conductor, but it's only sized based on that cable's potential ampacity and overcurrent device. When I put them in parallel to get more ampacity, now I have a bigger overcurrent protective device, and those equipment grounded conductors are too small. Okay, so what do you have to do? Now if they're in the same tray, I can run one single one, and then I have to connect all three of them together at each end at the equipment in order to meet this new rule, and that way I can still use a standard sized MC or standard sized tray cable in that application without having to get some kind of special cable made with a larger equipment grounded conductor that is full sized in each cable, okay? Because that's what you'd have to do if it wasn't in the same tray, okay? Anyway, and that's what we've done for years. All right, well, hopefully you understand it, got a little bit better understanding of that application. Again, if you have any questions, let's do this because you hear me talking, but you don't see me. You have any other questions? The key to remember again is I've got, if I'm going to use this allowance in B, which is 250.122F2, then you've got a B, you've got this two cables in parallel. Their equipment grounding conductors aren't full size. They're the size for that individual cable. When I put them on an overcurrent protected device to protect them in parallel, the code says if it's the same raceway, cable tray, or auxiliary gutter, that I can run one single one, full size, based on whatever the overcurrent device is that will protect that set. Now I can connect it at both ends with the equipment grounded conductors that come in those cables, and I'm allowed to use those stock cables, the ones that you can buy with the size equipment grounded conductor in that's normal, not oversized, okay? Hopefully you understood that a little bit. I know there was a little period in there where I was doing some talking and I forgot to turn the camera back on me. Hopefully by now you get it. You understand what we're talking about. If you have any questions, again, visit our website at www.electricalcodeacademy.com. If you're in Texas, tell people about it because we're going to be doing some upcoming continuing education seminars. If you're in a state that you'd like us to do some continuing education seminars, check whether or not they require formal a submission of code training, or if they do, we'll submit it and we'll get approved as long as you can get together and have a big enough venue for us to be able to do it. But really, we're kind of stuck in Virginia, excuse me, I said Virginia, in Texas. I was in Virginia, now I'm Texas. So we're kind of focused on Texas, but hopefully these videos will be able to help you and explain some things. If you have any questions at all, feel free to email me at info@electricalcodeacademy.com, info@masterthenec.com. Anything you want to text me, it's 540-607-0116. I just hope that you're respectful of the text and the time. But I'm here to help you any way I can. I am not a know-it-all. I learn something new every day. I like to share things with you. This is one that people will want to know about because it is a change and it does allow you to not have to order specialty MC cable or tray cable or SC cable or whatever. It is an allowance for you to be able to, I mean, the negative part is you're going to have to run an equipment grounding conductor unless, of course, your cable tray is in compliance with 392.60b. But if it's not, and you already have the stock cable, multi-conductor cable, then all you'd have to do is buy 4 gauge or larger, whatever the size would be based on the overcurrent devices for that set. Then, you know, this might be a game changer for you. It might be just a simple matter of running the equipment grounding conductor in there, and then once you get to a location where the cables actually leave the tray and go to the equipment, then you can bug off and actually continue that equipment grounding conductor down like it's supposed to be, okay? All right. Hopefully, I've helped you out a little bit. Again, if you've got any questions, visit our website, go to our message board, log on for a free account. You can ask questions. We'll give you answers the best we can. A lot of them's our opinion, but if we got a code reference, we'll give it to you. So anyway, thanks for watching, and I hope you got something out of the show. And until next time, thanks for watching here as we talk about the National Electrical Code.